Innovation isn't just about ideas, it's about turning them into reality. Meet Leonard Shayo, a visionary engineer and entrepreneur with a fervent passion for technology and innovation. His journey has taken him across multiple fields: communications, broadcast, embedded systems, aerospace, robotics, and alternative energy, all driven by a relentless pursuit of pushing the boundaries of possibility. From designing and testing a 1U CubeSat to pioneering Tanzania's space exploration efforts, Leonard is on a mission to redefine what's possible for his country and beyond. His expertise isn't just technical, it's a commitment to using technology to drive impactful change in society. Join him on this journey as he shares his latest project, building and testing a CubeSat, and how this innovation can pave the way for Tanzania's future in space exploration.
My name is Leonard Shayo. I was born and raised in Tanzania. I'm an engineer by profession. I started this journey when I was young. Since I was in primary school, I have been making, repairing, and designing electrical devices up to this day. My education, I did my primary school education. I attended secondary school in the Kilimanjaro region and also had the opportunity to come to Dar es Salaam to pursue my education for my first degree at a college. Dar es Salaam Institute of Technology. Also, after that, I got the opportunity to receive sponsorship to study abroad in Finland, where I was able to get my second degree, where I was able to pursue my second degree in the field of physics, physics of light. We can say physics of light in terms of how we can use light for the benefit of humanity or human lives. But before that, I did. So then, on that journey, after finishing my studies, I got a chance to go to work in the city, serve or engage in various writing tasks in several organizations here in the country, and also a little abroad, where I also like studying. I got the opportunity to work in those organizations in the fields of electronic engineering and international development. And physical engineering in the sense that I have participated in entire activities related to communication via computers, communication via satellites, which we will also talk about, and communication via security devices for Tanzania and also for the countries I have participated in, including Finland and including several African countries. It has been a long time thinking about matters of the satellite world. What is a satellite? A satellite is a device or instrument sent into space that orbits the Earth or orbits a planet. It remains at all times, 24 hours, in a position that we call its orbit or its path. Now, the main function of that device is communication. Samba, it's like mostly on a TV, mostly on the radio. Comma, to check weather conditions and also to check information or transmit location reports. For example, we use GPS on all phones. We say location so that you know where you want to go. You want to know how far that place is. All those tasks are done by the satellite. So you have a device to communicate with here on this Earth. You can say in many languages we call it a ground station. So you communicate with it, it gets this information. Besides those, the information on weather conditions, vegetation issues, agricultural issues. It also provides information on temperature issues, climate change issues. All these are some of the work. It can also be discovered, erosion and land statements, matters of cyclones, like matters of floods, how the weather is changing, at what rate and in which areas, people to take those precautions. I think we have already heard that weather forecasting. These things, they are enabled. satellite, 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 satellite. Our daily lives depend on each other. Our TV communications cannot happen without a satellite. For instance, we send pictures to space where the satellite is or in orbit, and those pictures are sent again to the ground in a different location. We can say it is like a repeater station in English.
Relay station here with things
Reading and conducting research related to various global disasters. Take a moment for your how is the weather? Wildfire, meaning a fire that spreads.
If you manage to handle it and so on. Therefore,
through that, I have been conducting research for several decades, ensuring how we can create such things. How can Tanzania participate? Satellites have been, the first satellite was launched. It went down in the year 1997 by the country of Russia. At that time, you were 20.
Satellite for various uses.
And I think it's important that Tanzania is considering how to achieve these goals as well, because of the benefits I have mentioned. So if we as a country, we can stay behind, they have done it, it's time for us to do it. So today, I will show you a prototype, 16 engineering modules of a satellite that I have attempted to build over several months now, and how it operates. And through this satellite, we can collect information, and how this information assists us in our research. This is the laboratory that I have built since 2017. It was my long-term dream to ensure that I have a place or a well-equipped laboratory that would enable me to realize my ideas. I bring you into the world in the simplest way, that I buy equipment one by one. I am starting to build building infrastructure, which truthfully, all my objectives are about the construction of my ideas. Kwa hiyo nilianza kununua baadhi ya vifaa kama unavyoona nyuma yangu, kuna oscilloscope, kiwamba cha meza na kadhalika. There are computers and monitors or screens to ensure that I can work at the highest level. And in its regard, when the exercise came, I tried to share with 2 or 3 of my friends, 4 people. They said, okay, it's a good idea and it's good we work on it. And I came up with the name Allspace and Olduvai Space Center. I would like to show you. The first step to building our satellite was to ensure we had all the necessary hardware, including the capability to reach a remote area where there is no signal. You can't plug in a baby and get a baby. So you must create an infrastructure that gives birth on its own and preserve the baby. So I must have the baby's preservation information. You must have information or hardware that processes the information. Because like a computer, we say microprocessor, computer, onboard computer, OBC. Another device that is important for all operations is speed, tunayoita sensor. Regarding climate change matters, it is therefore necessary to have those sensors which we also purchase and another communication device. So we say you must have communication between our satellite and areas for regular development. And the device that collects data, for example, if it is in orbit or in space, you need it to send data back to Earth. So radio, you can say radio or transmitter. Okay? So there is something called when you need to have. So telemetrics should pass through the satellite and come to Earth. So that is the whole process. So I started by designing on the computer. You design, you draw all your diagrams using special software. After that, you print the same design you did, then you say you want to fabricate. You fabricate in another machine. That machine, right now, we don't have in the country. Kwa hiyo unapeleka nyaraka na wanakusaidia na usajili. Prints come in this format. For example, this one here, as we say, this is a module. Yes, this is one module there. So right now, you were doing trials, but this is one module there. And it is all designed on the computer. I draw all the diagrams and arrange these components individually. Then I send them to the company that does the production. So they send it to me already completed, like this, after designing on my computer. Then for this, it is one device. For example, this here is one of the computers which, okay, it is exactly a complete computer. It is in our satellite. So this is a part of its rapid prototyping. So something becomes like this. A permit comes into this system. This is the base made, but this is the arm. And then before I'm gonna test here and assemble the circuit on one side with the machines there. And then I've already verified that the software and the sensors are working and everything. Then in a tumor, where there are companies producing, they send it to me. Once it's complete, and that part is hardware, and also you must program. You must do
Balancing that program
I mean,
a bit is one of the programs with me and Deka. We are confirmed with.
to ensure that it receives all the data on temperature as well as pressure and gets it from these codes. And this is one example here. And there are many codes. And here I am talking about the software side now, because when you do anything on the hardware side, you also know how to do it. I also work on the software side. So this is just one example there that I've written for those talking about programming who want to understand well. This is software, and it's called Microsoft Code. So it is one of the tools you use in writing. So
This is an example of the programming I used to do.
let me just stop here. I am testing and with my module to ensure that these codes have been loaded into our microcontroller or microprocessor or onboard computer. After that, they are processed and function as they should. May our device has intended, the device itself, let's bring those here. After the whole process. Hii ni satellite ya centimeter.
Kumi.
This is the 1U satellite, as we call it, or the CubeSat 1U. But due to the installation of these solar panels, I added a little space so that these panels can fit. So these panels have been added by about 2.5 centimeters. They are built to that standard so that they can be loaded into the rocket and launched into the respective orbit. Therefore, the minimum dimension for this standard is 10 centimeters, where it is loaded. Another device is called the P-pod, or Polypico Orbital Deployer, when we say, or dispenser. Once inside, these antennas are like this, is inserted like this. When it enters, once it reaches the OB2C, those 400 kilometers, we say it is possible. They reach 400 or 300 or 500, depending on they become like this, V. For example, you will see, at first you said, why have I put? I have put these, and they are for measuring, and they are. But because their material can bend and open without damaging or folding, they revert there, and these are these types.
This is the antenna.
Used for satellites in countries of this size. So after entering that bit, it starts to rotate. Ground station antenna. Antenna frequency, operating frequency, operating frequency.
Then the other one is this one. So this one is for GPS or to show the...
Kolokechingani transmits location information where this device is at all times. Similarly, as it was previously mentioned, it must produce electricity through these solar panels, and that's how we get electricity. Generate electricity as you enter. After that, there is a battery inside to store electricity. Since it is now in space, I can also charge or input electricity through regular power. Because there is a port here, type C, an indicator, I get electricity, and here is a port. And this is RF45 Ethernet. So this is just a brief explanation of what we are going to look at and what I have explained on how it works. Also, another thing, these balls that I have placed are not just for holding everything together. Hii hapa ninashikilia na kukufungia kama nilivyoongeza baadhi ya paneli ambazo zitakuja kukaa hapa juu. 1530. The resources and that, when they are here on the ground, you can make use of them when you are present. You can use them on your farm. You can reach your town by going to give you information. All that we are saying, we're not here below before setting off. Now we will start it up and observe. Hii ni dashibodi yetu kama unavyoona.
I am announced for giving on
A direct report just as it was without saying there or on this side.
Information regarding health metrics. On our satellite, it's 100%, more than 100%. And if it drops, for example, at night, there's no power. If in orbit, how? So the reduction there is where you get that information. Here is the level of pain. More here is the altitude, meaning the level from the sea, where you are. For here, the area we are in, we are 72 meters above sea level, not very far. We are in Dar es Salaam. So the sea is in Dar es Salaam. And our device in this area where we are is 72 meters. The temperature level, the pressure is also, I get its readings. It is, let's say, hectopascals, or 1992. Now here there is something that we are also learning. We have learned that as you continue to go above sea level, every 100 meters,
Quasi then goes
from sea level, every 100 meters, the pressure decreases by 1 hectopascal. Here, right now, it is 172 meters. If we leave the city a little, going to another region,
You'll see the pressure
kidult.
decreasing on the lower side.
fungus, that's
In
how
the
the
world,
implementation
it's
works.
light.
The higher you go, the more the pressure decreases. The pressure decreases because the air molecules decrease. When air molecules decrease, it means the pressure becomes lower. So. The higher you continue to go, the pressure keeps decreasing. Inside here, I think you will see this level of humidity here. 65%, 65% exactly. It's good for human health. You know, if it increases a lot, reaching 80, it means the level of humidity. And if it gets too low, that's a problem. For example, in the upper regions, if the humidity decreases, you'll start seeing lips dry up, breathing sometimes it happens like that. Or even when you're in AC as well. If our equipment there has AC, I would show you how the air has and the state of moisture or humidity. Similarly, choto au hali joto linaelezewa hapa, tutafanya majaribio madogo kuona kama vyombo vyetu vinaweza kutoa joto tofauti. Tutakachofanya ni kuwasha hita, tutajaribu kuchukua joto tutaona hizi namba hapa zinatofautiana. Kwa hivyo tutawasha hita yetu. Father, this is our heater. We call it a hot air gun. It releases heat. So if you look, you will receive those right now for 1.5. For our device, we do not want to turn it on too much. We do not want to input too much heat. We will start to see on the dashboard, it changes. Without burning it, we want to see how the temperature will change. All our sensors are inside here. We give heat or we give heat to our satellite. So right now at 6 hours and 1.5, the temperature started to stabilize. You are observing that it is changing. Now it is at 1.6 and it's starting to rise.
When there is a problem, it plays a little.
I know how the humidity changes because these are your temperatures in one way or another. It will reach 1.6.
Bali takes a little time because here the air zone changes
slowly. High. After that, now we expect to see possibilities. Big things happening and 1.6 still.
Kubuka. We are in stopover League 7.
Wine changes slowly. Attitude keeps you away from places without blessing or pressure because our container is coming closer anywhere. Dynamometer 1.8 will increase like that gradually. For example, if you look there on the dash on our graph. On our graph, 8:30, 12:30. When we started heating or increasing the temperature, you can see the graph started rising slowly. 31.9, the temperature is still there. It means our equipment is working. This is a graph showing temperature. It shows the temperature rising because the heat is still there. That's the temperature side. We go here. There is something called magnetic field strength. These are the levels of magnetism that I told you surround the Earth. Here too, there are many and good explanations about how the Earth was formed and its wonders, that the magnetic forces generated from the center of the Earth are the ones that circle the Earth, surprisingly like at home. Our device will also be involved in observing how those changes can be captured and clearly show that, okay, so it is. The Earth has such things. This is one example of them. I created this dashboard to simplify the reading of this information. You get all the information there. You get all the information here. Okay, so this I have called it Revolution Satellite. It will be called Revolution Satellite 1. 2 is for dashboard, but Mapinduzi Satellite 1 is our name of our satellite. And here I wrote it in terms of Tanzania, because this is the satellite of Tanzania. This is the official statement that our satellite is functioning as intended. And after discovering that, another final test, all these things we are doing here in Dar es Salaam, we will do in Morogoro, and we will also do in Singida. To begin with, it is the first test to see if there really are these changes that we intend. Testing pizza.
We will continue to get that information.
Remember, the satellite is just going into low Earth orbit, that is approximately 400 to 500 kilometers from the Earth's surface. Can we get this information? Okay, another thing. Can it show whether our radio is transmitting those signals to reach us? And what I can do? Ground station computer it uses radio here. We call SDR software. Defined radio for purposes of waking up. when he goes to do the final trial now to confirm that, yeah, our equipment it emits the necessary waves. For all the information that we have described, we would see them in something called the radio spectrum, in the frequency waves that our radio will be. This software is called SPY SDR. It enables us to make decisions on see truly in our areas. It travels in a megahertz of 433, therefore.
So our features are here.
For us, the committee sees that what appears here is the reality of what it is saying. When it is in orbit, the first thing you will check is to ensure that your satellite is active. You see, this is the signal carrying all the important information we mentioned earlier. Kwa hiyo, baada ya sekunde chache, inakutumia ujumbe. Baada ya sekunde 2 au 3, unasikia beep beep beep, ambayo ina maana kwamba betri inaisha. The satellite functions and those antennas work in the sense that they transmit the signal to reach the detection device or ground station. For today, that's what we're excited to talk about. There's more coming. We are now going to test outside the laboratory from here in the laboratory. Let's go to these regions to see the information we gather. Baada ya hapo, majaribio kadhaa yatafanyika kama vile majaribio ya masafa na majaribio ya. Several adjustments were made to modify the structure and place it in the form of 1U or 2U.
Leo, we have concluded the journey to the Uluguru mountain range. As you can see behind me, it is a fine location at the same sea level where it will give us a complete picture of how our device can collect data that we kama satellite katika mzunguko inafanya kazi kwa njia ile ile. This satellite, which we call an engineering model, will be able to work and allow us to collect data that we can describe initially while at our workshop. And as you can see, I came with a bag. We are in the Kilimani ward. Right now we are at a height or distance from sea level, how much pride. But our satellite will tell us, our satellite is here. It's called Mapinduzi Sat or Mapinduzi Satellite 1. And I will go to open, you will do the assembly of everything here and start conducting the very first tests. Nizami says the first tests in Tanzania to be done by a private company. The satellite tests, the first ones, let's go. I sneezed. No worries because it is high up and you can see the city. We have chosen. Okay. Laptop is. I don't have a single dragon. Here is our satellite. I think you will remember it. We have explained it a lot while we were in the workshop. Here we are conducting the first trials with something else we will need. We will need a configuration cable very soon so we can turn it on. We are sure that from the box you see it is surrounded by. Right now we have come with a little evening media. I know it sets, but its battery can store power for approximately up to 10 hours without relying on solar power. At this time, we are completely sure because it used to be itching. We are sure that the electricity present, they are enough to gather this important information.
First, we will start it up directly.
Okay, I'm leaving. I think you will see there's light inside. From above, you will see we have already explained it well there. Right. Straightforward. I am going to first check the condition of this device, which we have traveled with from Dar es Salaam to here. We are opening our laptop, which is currently our base station, or what we call the ground station.
Well, we will be able to see information
of the satellite. Therefore, after checking that, we call it the onboard computer is working. You get responses from our significant instrument. After turning it on, our device is functioning well. It is correct, it is ready, and it has already started processing data. Therefore, what I will do is I will call the page of...
There's a system that shows you all the sensors. There are close to 6 of them, all of them. Take the information and store it and start sending it. Okay, all right, here are the reports. Faces appear on the satellite dashboard. That is, the reform is present. Doing it in real time and talking about what is happening on the Mwanza board, the reform is present. Bed free. $918 HPA. Do you remember the one for Dar es Salaam? How much was it? Along with Morogoro town. How much was it? Humidity level, the amount of water vapor in the air, we have 72%.
This is a very large research.
What climate change is doing right now is that the world is surrounded by magnetic forces that, for those who know, are called the magnetosphere, which protect us from radiation from the sun. Interaction here, microtesla, 1999. There is also information concerning the computer that is on our satellite, its current status. You will see there is a central processing unit, usage level of 3%. There is a level of random access memory, or RAM. That level here you see is 58.3%. The current temperature of our computer, as our machine continues to work and collect this data, is 80%. Machines like the computer, can overheat to 42.9 degrees centigrade. Similarly, there is a storage space utilization rate of 53%. All of this is information we receive from our satellite machine. We will take note at this stage. By the way, as in the case with from sea level, and likewise we are here at 822 meters from sea level. Those are the details here. Then there is another study we will be testing. These details we will receive. Remember, the satellite stays 400 to 500 kilometers in something called lower Earth orbit. I mentioned it at the beginning, and those details are sent every second coming to Earth. Does our instrument, it has that capability, so that and the second test we will conduct, we will ensure that we do it over a greater distance. For now, today, we will just demonstrate this mission, meaning this information or this signal or that signal we can obtain. Now here we have set up our ground station, as you can see, and we stated here it is around kilometers. 10, 10 and something, about 15 at the level where our satellite is. As you can see on the screen, we are getting a good signal. We have an antenna here. It's not Yagi or dipole, but we will do that in the second test. But so far, we are getting a good signal, and the antenna is giving us good results. Kwa namna moja au nyingine,
You can see it like that.